Welcome back to Broken to Built. Today we're facing a mechanical nightmare, a heavy-duty drive pinion that is sheared clean in half. This component is the heart of a vehicle's final drive, subjected to immense torque and hardened for durability. Usually a break like this means the scrap bin, but today we're going to perform a mechanical transplant to fuse these two halves back into a single high-strength unit. We start by mounting the gear side of the pinion into the lathe. Our goal is to create a perfectly concentric bore. We aren't just smoothing the surface, we're machining out a deep internal pocket to house a structural sleeve. Because the steel is induction hardened, we have to use high-grade carbide tooling and slow, deliberate passes. Once the bore is true, we move to the shaft side, machining it down to create a matching male pilot that will slide into our newly created housing. To ensure this repair doesn't just snap under load, we're implementing a dual retention system. After machining the mating surfaces, we cut precision internal threads into the gear housing and matching external threads onto the shaft. This creates a massive amount of surface area for the eventual bond. This thread and lock geometry ensures that the rotational forces of the engine are distributed through the steel threads, not just the weld bead. Now we marry the two components. It's a high-stakes moment. If the alignment is off by even a fraction of a degree, the gear teeth won't mesh with the ring gear, leading to a catastrophic failure. We use a heavy-duty lever to thread the shaft into the gear until it bottoms out completely flush. By achieving this interference fit, we are ensuring that the structural integrity of the pinion relies on a physical mechanical union rather than just the surface tension of a weld. Now for the structural backbone, the welding phase. We are laying down multiple passes of high-tensile filler material around the seam. This isn't just a cosmetic joint. We are aiming for deep penetration to bridge the two halves into a monolithic structure. We are utilizing a specialized cooling process to manage the heat-affected zone, ensuring the gear teeth retain their original hardness while the new joint gains the necessary ductility to handle sudden torque loads without becoming brittle. Every drop of filler is placed to minimize internal porosity, which is the leading cause of failure in high-torque gear repairs. The final step is to bring the gear back to its original geometry. We return to the lathe to machine away the excess weld slack and restore the pinion's outer diameter. We then use a precision grinder to hand-blend the gear teeth profiles where the break occurred, ensuring a seamless transition for the lubricant. This delicate hand-shaping prevents high spots that would cause gear whine or chipping, while a final digital measurement confirms the assembly is perfectly balanced for high RPM operation. We're essentially checking for one out down to the micron level to ensure this doesn't tear itself apart inside the differential housing. From a two-piece pile of scrap to a precision-engineered drive component, this pinion is now ready to head back into a differential and handle hundreds of pound-feet of torque once again. It's a daring repair that challenges the replace-only culture of modern mechanics by proving that engineering skill can restore even the most far-gone components. If you want to see more unfixable parts get a second lease on life, hit that subscribe button. I'll see you at the next rebuild.